Hello everybody. Welcome back to another session on logic development. Now that we have completed discussion on selection and the sequence construct, it's time for us to go ahead to the next type of construct, and that is iterative construct. We said there are three major constructs: sequence, selection, and iteration. So today we'll start our discussion with iterative construct. So let's begin with our discussion about what iterative constructs are all about. So when I say iteration, we mean repetition. So when we have to repeat certain things again and again, we go in for this iterative constructs. So let's begin with our discussion on this iterative construct. So today we'll be discussing problem solving with loops. Now when I use the word loop or iterative constructs, it's one and the same. Loop means you keep on doing certain things again and again. It's an iterative construct. So the loop logic structure is a repeating structure. So when you come across a scenario where there is a single statement or there are a group of statements which you need to execute repeatedly, in that case, we go ahead with this iterative construct. Mark my word, if there is a single statement or there are a group of statements, but if they need to be executed repeatedly, we go in for this particular construct. And a lot of times in business, you actually come across this scenario. You may be unaware that this is happening, but this is the most commonly used construct. The data on which the operations are performed may vary, but the operation that we are trying to perform on the data still remains the same. So we go about carrying out similar operation on set of data. Now let me help you explain this with a real-time example. That will give you an idea as to whether the same thing is applicable or not. Now, many of you or almost all of you are from Maharashtra, except for 2-3 of you who are not currently in Maharashtra, but all of you are from Maharashtra. Now, Viraj, tell me, do you have electricity at your place?
Yes, sir.
Yes, Viraj?
Yes, sir.
And it is free for you?
No.
No, it is not free. Definitely not free. Okay. And Ashish, is it free for you?
No, sir.
Definitely not. Okay. You may be at two different corners in the city or in the state of Maharashtra, and both of you have to pay the bill. Now, Viraj, the bill that you pay and bill that Ashish pays, does it have to be exactly the same?
No, sir, it will vary.
It will vary. But then, are different rules applied to you and different rules applied to Ashish?
No,
If both
sir.
of you are taking electric supply from MECB?
No, sir.
No. So every household that is there in Maharashtra, say Maharashtra's population is 12 crores, and let's say there are divided by 4, suppose there are 3 crore household in Maharashtra. So all those 3 crore household probably will be having an electricity meter. Okay. Now, if you have an electricity meter, calculations are to be done. Readings are to be taken. Now, when they take a reading, there are various slabs. Like the first 100 units will be charged at this rate. The next 100 units will be charged at this rate. And further units will be charged at some other rate. So there are different rates at which the bills are actually charged. Charges are calculated. But the formula that is applied to you or the formula that is applied to Ashish still remains the same. But then you two are not the only customers. There are 3 crore customers that probably MECB has. And then they end up doing calculation, applying the same set of rules for different set of data, different customers, and then they generate the bills. That means the same program reads the reading that they may have fed in Excel file or whatever file they may have fed in with your consumer number and your consumption, electricity consumption, or your current reading, because they already have your previous readings. So the program reads the data, what is the consumer number and what is the current reading, and then accordingly it will calculate what was the previous reading, then how much what are the slabs are there, first slab, second slab, third slab, and whether you paid the last bill or not. Based on that, it generates the electricity bill. Now, same calculation is done repeatedly for every customer who has an electricity meter installed at his place. So that system runs 24/7, repeatedly performing same operation over different set of data. So the only thing that is changing over here is the data, but the operation that is being performed is exactly the same. And the same operation is performed repeatedly over different set of data. So the data is changing, but the operation still remains the same. The outcome is the same. It's the meter bill that is to be printed. The values inside the meter bill can be different, but the output is the same. Output is same means the operations that they are performing, the calculations, the logic for the calculation is the same. Now here, have you noticed the same operation was performed repeatedly for different set of data. Now you can extend that particular logic to anybody. Now you appear for university exams. Now you are not the only one who will get the mark sheet. Every student who appears for the university exam, with respect to whether he fails or whether it passes, he will get a mark sheet. The logic that is applied for a, say, first year student in University of Pune for engineering course, the same logic will be applied for all the students, engineering students for the first year. The marks will change, but then the calculation, the logic that they do, if the passing marks for some subject is 40, so it's going to remain 40. If the passing marks for some subject is 50, it's going to remain 50. Based on that, the outcome will be done. But that means the same set of operations of checking whether the student has passed or failed will be performed repeatedly over a different set of data. Now, there may not be 3 crore students in Pune University student, but there could be at least few lakh students who are learning at Pune University. Now, every time the exam gets over, the system comes into action, the application, the program comes into action, and then reads the data, the performance of every student, and then generates a mark sheet and also a grade, whatever grade the student has secured. Now, these 2 examples are good enough for you to understand that same operations are performed over a different set of data. First student, second student, third student, marks may be different, but the operation that is being performed, the rules that are being applied still remains the same. So when you come across a situation where it's the same operation that we have to do perform repeatedly over different set of data, you should always think about iterative construct. So here I said most problem in business involve doing same task over and over for a different set of data. Look at that mark sheet printing, same task to be done over and over for every student. Bill printing for MSCB, same task to be performed over different set of data for different consumers. This is the most commonly occurring construct that you'll come across when you come across in programming. The loop is also used to return the processing to an earlier point in the solution. Till date, what used to happen is you use pseudocode or flowchart. The flow was continuous. Once you go down, then there is no way we can come back. Now here that is not the case. Here we can return to a particular part in your program. Okay, it is similar to go-to statement, which we will try and avoid. A lot of languages do have a support for go-to, but we'll intentionally not look into that go-to. It's a bad programming practice to use go-to unless there are some exceptional cases where we need to use go-to. Otherwise, I'll not use this go-to neither in programming, neither over here. The pseudocode and flowchart differ for each type of loop structure. That means there are different loop structures which are there. So there is not one iterative construct. There are multiple iterative constructs which are there. Now, when you write your code, I'm saying over here, it is extremely important to indent. Remember that if else also when we used to write in pseudocode, we have been indenting, we have been leaving spaces from the margin so that we understand where that if starts and where that if ends. Same is the case with looping construct as well. It is very important for you to do proper indentation. Otherwise, it is very difficult to read the code. And especially when you have a loop within loop, nested loop. Okay. So many of the languages will provide you braces, curly braces to specify where which loop starts, which loop, where the loop ends. Some languages like Java will give an opportunity to give a name to a loop also, but that is not available in every language. So this indentation makes the representation of the logic clear so that the person who is maintaining the code will not get confused. He will know which are those statements whose execution is performed repeatedly based on the condition of the looping construct. So indentation, leaving the margin, space from the margin is very important. Representation of code is also very important. There are different types of loops that different languages support. While, end while, repeat until, or do while. Now, why did I say repeat until or do while? Let me just touch upon this. You'll almost always have while loop in every language. But in most of the languages, you'll either have repeat until or do while. I haven't come across a language where both these loops are provided. It's either repeat until or do while. While is almost everywhere. And then there is automatic loop called as for loop. That's also provided with most of the languages. It's just a different way of representing while loop. But amongst the repeat until and do while, I have seen only one of the two loops is being provided in every language. So there is some difference between while and for and the repeat until loop that we are going to talk about. Today, we are going to use a concept called as indicators. Now, they are logical variables that the programmer sets in the program to change the processing path or to control when the processing of the loop should end. We call them as loop control variable. These are indicators. These indicators indicate when the loop should stop. Remember, in flow algorithms, we said earlier, every program should stop somewhere. Right? It should not happen that the program just keeps on running infinitely. That should never happen. So every program has to stop. It should give an answer at some point of time. So if you are running a loop, you are doing some operation repeatedly. But repeatedly, how long? Lifelong? No, it has to stop somewhere. So there will be some variable whose value will indicate when that repetitive operation should stop. That's my indicator. That's my loop control variable. And we have to be very careful when you use this loop control variable. This loop control variable will be used to specify the condition which will determine the termination of the loop. When will the loop stop? They're sometimes called as flags, switches, or even trip value. So if somebody says loop control variable, somebody says flags, somebody says switches, somebody says trip values, it's all the same. That means these are variables whose values determine when the loop will terminate. When the loop will terminate. You may call them by different names. The user has no knowledge of these indicators during processing. So you have to express this logic in your code itself. Now let's focus on this first form of loop, which is the most common form of loop called as while and while structure. Now, here it says this type of loop tells the computer that while the condition is true, repeat all instructions between while and end while. So while and end while should come in one line. And the set of instructions that we want to execute repeatedly should be indented from the margin. Means if I write while over here, and so in the same line, I should write end while, where all the statements whose execution depends upon the loop should be indented from the margin. You should leave some space from the margin. So if this is while, this will be end while, and this will be the body of the loop. And note kijega, body of the loop will be indented from the margin. So we know this while loop starts over here and the while loop ends over here. Whatever is between them is executed as long as this condition evaluates to true. So representation is very, very important. How you represent, because one of the parameters on which we check the quality of a program is how easy it is to understand and maintain. And that means how readable the code is. And to improve the readability, representation is very important. So we write while, whatever condition that you may have, and then the body of the storage loop, whatever statements, and then what we have is end while. While, condition, end while. That's how you represent. Whatever the instruction inside it, they will keep on executing repeatedly as long as this condition is true. What do I mean by that? I mean, first it will execute all the statements over here, come and check for the condition. If the condition evaluates to true, the control will go inside. But after executing all the instructions, it will not come out. Rather, after executing all instructions, the control will go back to the condition once again. Again, it will check for this particular condition. Again, if the condition is true, again it will go inside, execute all instructions. But after executing the last instruction, the control always goes back to the beginning of the loop. This will keep on happening repeatedly. How long? As long as this particular condition evaluates to true. The moment this condition evaluates to false, control will jump out of the construct. Look over here. I say while condition, if the condition is true, we go inside, we execute the instruction, whatever the instruction says. But after the last instruction, the control goes back to the condition. We will keep on doing this thing repeatedly. How long? Till the time the condition is true. Moment the condition becomes false, the control will come out of the loop. We will proceed with the further operation that we have to perform. So that's how while loop really works. Now there are scenarios when to use while loop, when not to use while loop. So here we put across a condition. If the condition is true, we go inside, execute the statements. We keep on performing this operation repeatedly. How long? As long as the condition is true. Moment the condition becomes false, we come out of the loop and so on. Now there are cases where this loop is recommended to be used. At the beginning of while loop, the program processes the condition in order to decide whether to execute the looping instruction. That means at the beginning itself, it will check, it will check for this condition. And the result of the condition will decide whether to execute the statements which are present inside this body of the loop, these statements. When the result of the condition is false, at the start, the instructions in the loop will not be executed. That means if it so happens, first time we are checking for the condition and the first time itself the condition is false. So in that case, what will happen? You are checking for the condition for the first time and first time itself the condition is false. So control will directly jump over here, means these instructions may not get executed. So in while loop, there is no such compulsion that the statements which form the body of the loop will always get executed. No. If the condition is false for the very first time, the path that will be following is this. So these statements may get skipped. But it may happen the condition is true. If the condition is true, only then these statements will get executed and then again it will go back. So there is always a possibility while using while loop that the statements inside the body of the loop may not get executed. Why? Because the condition may be false for the very first time. When the resultant of the condition is true, the complete set of instructions will get executed and the computer will go back to the beginning of the loop and process the condition again. That means if the condition is true, we'll go inside the body of the loop, execute the statements, and again go back to the beginning of the loop. So this is a construct which takes the control back to the beginning of the loop and so on. The loop will repeat until the resultant is false. And jab tak wo result condition does not become false, it will keep on executing the statements again and again. Use of end while structure when there are cases when instruction the loop should not be processed. In these cases, result of the condition is false at the start of the loop, so it is not processed. So it is giving us a hint when to use while loop. You should use while loop where there exists a possibility that you are not required to execute the statements even once. If such a possibility exists, then you can go in for this while loop. There is one more condition that determines when to use this loop. When you especially do not know the number of times the instructions are to be repeated. How many times this operation is to be performed? If you do not know about it, then definitely think about using while loop. So use of while loop structure, use the while and while structure when you do not know the number of times the instructions will be repeated. If you do not know whether I should perform this operation 4 times, 5 times, 10 times, when you do not know, in that case, you should go in for this loop. In such case, we ask the user to enter a positive number. If the user enters negative number, reprompt this and until they supply the positive number. That means we are going to go ahead accepting the numbers from the user till the time user doesn't enter positive number. Now, do you know when will the user enter positive number? User may enter 100 negative numbers and then he may enter positive number. User may enter the positive number the very first time. That can also happen. So here, when we do not know the number of times the operations are to be performed, think about using the while and while loop. And the loop control variables are also called as sentinel values. As long as the Boolean expression remains true, while loop executes the body. Must control the repetition to avoid the infinite loop. Infinite loop is a construct which is very dangerous, where the loop never terminates. It just keeps on doing that operation forever. So that should never happen. So your loop control variable, your sentinel variable, your flag, your trip value, that decides when the loop should stop. So repetition can be controlled by counter and by sentinel values. And that is what I'll demonstrate with some examples. Now, my initial set of examples that I'll be taking up today may not be the best cases for which we should be using while loop. Listen what I'm saying. May not be the best cases for which I'll be using while loop. Then you may ask me, sir, then why are you doing that? Oh, I'm doing that with a reason. My first concern or objective is to make sure that you understand how to use the loop. So once you are comfortable understanding how to use the loop, then we will think about the scenarios where this loop should be used and how efficiently we can go ahead using the loop. So that's the second part of our discussion. First objective is to make sure that you are comfortable with this kind of loops or loop iterative construct. So my examples that I take initially today may not be the best examples or scenarios where while loop is to be used. Probably for loop can be used for that purpose. But I still take that example. So to get you accustomed with this iterative construct. Okay, so let's begin with a set of examples. Before that, if anybody has a question, please ask. Yes, anybody has any question? Have you all understood what we have discussed so far? ओके संजय क्या डाउट है? संजय व्हाट्स द डाउट? Let's begin with an problem statement first. So please note down the problem statement first before we go ahead and making an attempt to solve. Very simple examples we'll start off first. Accept an integer n. Accept an integer n and display all integers and display all integers in the range of and display all integers in the range of 1 to n in ascending order. Very simple question. I know many of you know the solution as well, but we'll still go through it. Accept an integer n and display all integers in the range of 1 to n in ascending order. Now, so the question, if you look at, it's about printing numbers in ascending order. But then it says from 1 to n. That means you will accept a number. Say user says 5, you will start from 1 and will go till 5. So we have to accept ask the user how many integers you would like to display. Because starting value is always 1. So obviously we do not want him to enter the negative numbers, because starting from 1, if you have to display the numbers in ascending order, it will only be like positive number. From 1 to n minus 5, ascending order mein nahi hoga, starting from 1. So let's draw a flowchart and a pseudocode for the same. Here we go. So we start with a flowchart. We'll have to define the variable first. We declare the variable. I'll call this variable as limit, because we are going to ask the user when to stop. So it's an integer variable, limit is what we have. And then we'll have to count how many variables, how many values have we currently displayed. So I create another variable called as counter. That's also of type integer. So I define two variables. One is limit, another is counter. Then I'll ask the user to enter the limit, or to enter a positive non-zero in a positive integer, and that to non-zero, because we are supposed to display all integers in the range of 1 to n in ascending order. So 0 hoke bhi nahi chalega. So I'll ask a proper question to user. Please enter a positive non-zero integer. So I have asked user to enter a positive non-zero integer. So user may enter some value. So user inputs a value, and that I store into a variable that is our limit, because that's where we have to stop. Now, if user says 5, I have to start with 5 and print the number still 5. So this counter is something that I'll have to initialize. So I'll have to assign this particular variable counter the starting value. So I'll say counter is equal to 1, because you have to start with 1. But then if I only want to display the value of counter, that would not be enough. So if I say counter and we display the value, or the integers in the range of so and so is, if I say, okay, if I say integers in ascending order starting from 1 are as follows. I have given some messages though, and then we display counter ka value, and then we stop. Now if I do this, counter ka value is 1, only 1 will get displayed. Let's see. We start with the code. I have been asked, please enter a positive non-zero value. I enter 4. And what it has done? Integers in ascending order, starting from 1, are as follows. It has only displayed 1. And because this operation was done and the program has stopped. So I want to perform this operation repeatedly. Every time I want to keep on performing the same operation. So in such cases, we go in for a loop. Now, here is a loop that we are trying to use. So I say while, and I give a condition. I'll say while counter less than equal to limit. Till the time the value of counter is less than equal to limit, I'm going to take this particular variable and I'm going to print it over. And I'll keep on doing this thing repeatedly. Kab tak? Till the time this condition is true. Moment this condition becomes false, I'm going to come out of the loop. That means if the condition is true, I'll go here, execute the statements, and again I'll come back. If the condition is true, I'll go inside, I'll execute the statements, I'll come back. I'll keep on doing this thing repeatedly. How long? As long as this condition is true. The day when the condition becomes false, we'll come out and we'll stop. Okay. So we have been outputting the number. Let's see how does it work now. Let's execute it step by step.
आउटपुट मध्ये टाक.
It's a statement needs to complete. Output में कुछ लिखा ही नहीं. Output में counter. Okay. Now let's execute the code. We have this counter variable that is there. Let's also see the variables. Watch this variables over. Okay. So watch this. Now I'm going step by step. We will not execute all instructions at one go. We are here now. Please enter positive non-zero integer. So next step, it says please enter positive non-zero integer. Now that we have got this particular statement, I enter integer. So we have to input. So for input, I go to the next step and I input the integer. Say I input integer as 4. Suppose if I input integer as 4. Let's start again. I'll say go very slow. Watch it. We're asking to go slow. And then we run the code. Here we go. We have been asked to enter the number. I enter number like 4. Watch it. When we enter the number 4, it comes here, it checks for the condition. And it look at this. For the first time, it checked for the condition. Okay. Second time, third time. And then the fourth time, you just keep on doing this thing again and again. Let's see how. Watch. Here it has printed only value of counter as 1, 1, 1, 1, 1, and infinite chal raha hai. It is not getting terminated. Look at the memory over here. The variable that we have over here, there are two variables. One is limit, another is counter. So we are checking is counter less equal to limit is 1 less equal to 4 true hai. So it is going inside, printing the value of counter that is 1, again going back and checking is counter value. Look at this counter value 1, 1 less equal to 4 hai kya? Ha, true hai. Are this is always the true. 1 less equal to limit will always be true. So since the condition always true, it just keeps on doing this thing repeatedly and it will never terminate. So it is now become an infinite loop. And there are several times we have just ended up printing 1, 1, 1, 1. It is printing only 1, 1, 1, 1, 1, 1 every time. This is a big problem that we come across. Okay, so how do you handle this situation? Let's see how to handle this particular situation. So I terminate the loop. Here we are checking condition is counter less equal to limit. For the first time, the value of counter is 1. Limit value is 4. So we check is 1 less equal to 4 true hai. If it is true, we go inside and we reach over here and we print the value that is 1. But if I directly go here, 1 is decimal limit, that's always true. So here I'll have to make a change. I'll have to change the value of the counter. I'll have to increment the value of counter. So I'll say counter is equal to counter plus 1. Now what will happen in this case? Say for the first time counter value is 1. It prints 1. And counter is equal to counter plus 1. 1 plus 1 becomes 2. So if it becomes 2, we again go back and we check. Is 2 less equal to 5 or 4? That's 2, it will print counter. Then it will become 3. 3 is equal to 5. Yes, it will print 3. It will become 4. 4 is equal to 5, it will print 4. It will become 5. 5 is equal to 5, it will print 5. It will become 6. 6 less equal to 5, it will come out. Let's see how does it work now. So we'll again run this particular code once again, and we'll see how does this particular program behave. Watch the variable list very, very carefully as we go about solving this particular example. So we have variable limit, which is not initialized. It may have some garbage. We have counter that's also not initialized. We prompt the user to enter a non-zero value. So we come here and we are accepting a number. Look at this. So I accept number 4. Watch it very carefully. Yeah? I accept number 4. So limit value is 4. Limit value is 4. Okay. And see what is happening. Counter became 2, then 3. I'll run this particular thing step by step so that you'll understand it much better. But look, watch it. A 1, 2, 3, 4, and then the program terminates when the counter value has become 5. So let us do it again step by step to understand how does it really work. Let us not run it directly. I wonder why, how did it get what I had executed directly. So let's execute it step by step. We ask the user to enter the number. User enters number like 4. Okay. User has entered number like 4. Limit may be uninitialized. Yeah. Watch it very carefully. Then we are going to set the value of counter to 1. Counter therefore you feel uninitialized. So I'm going to set the value of counter to 1. So I set the value of counter to 1. Counter value 1. Then we are here at the condition. Look at the condition that we put. We will not use the diamond for looping condition. For looping condition, we'll use this hexagon. 1, 2, 3, 4, 5, 6. This is what we'll use because that will differentiate between the looping condition and the selection construct. So here we say we're checking counter is limit hai kya? Dekho ya counter value kya 1. Is 1 less than 4? Is 1 less than 4? True or false? Ye dekho counter value 1 hai. Is 1 less than 4? True or false? I say something. Is 1 less than 4? True or false?
True, sir.
True, sir.
True. If it is true, the control should come inside and print the value of counter. Watch it. Control go inside and prints the value of counter. 1 has been printed. Counter value filal 1 hai. Now we are here and we are saying counter is equal to counter plus 1. Counter value is 1. 1 plus 1 now becomes 2. It has become 2. But after executing all statements in the body of the loop, control has gone back to the condition. And again we check, kya counter is equal to limit hai kya? Is 2 less equal to 4? Is 2 less equal to 4? Condition true or false? True.
True, sir.
True hai. If it is true, then we again enter inside the body of the loop. And we print the value of counter. So 2 has got printed now. First time it was 1, now 2 has got printed. Again we say counter is equal to counter plus 1. So 2 plus 1 will now become 3. Watch 3. Counter value has become 3. But from here, the control has gone back to the condition. Now again we're checking, is counter is equal to limit? Look at this value of counter 3. Is 3 less equal to 4?
True.
True.
True. Yes.
True. So we again go inside. We print the value of counter once again. That is 3. And we are checking counter is equal to counter plus 1. 3 plus 1 now becomes 4. Huh? And then again go and check for the condition. Is 4 less equal to 4? Condition is true. So we'll go inside, print the value of counter that is 4. But 4 plus 1 will now become 5. And again go back and check for the condition. Is 5 less than or equal to 4? Look at this. Is 5 less than or equal to 4? Is that true or false?
False. False.
False. 5 less than or equal to 4, condition is false. So since the condition is false, it will no longer go here. Rather, the control will come this side. Watch it. The control comes here and the program is stopped. So it has printed numbers in the range of 1 to 4. Now let's run the program directly. Okay. And let's also increase the speed fast. Let's see what happens. Yeah, medium pe run kar dete hain. There you go. We'll run the program and we enter the number like 10. So in this case, we'll print numbers in ascending order 1, 2, 3, 4, 5, 6. It chal raha hai. till the time counter value is less than equal to 10. Counter becomes 11, it comes out. It has correctly printed the numbers in the range of 1 to 10. Now it could be any number, 1 to 100 भी print कर सकते हैं. So if I have to perform that operation repeatedly, I'll always go in for loop. So even if I give a number like 100, you print the numbers in the range of 1 to 100. A 1, 2, 3, 4, 5, 6. It is printing those things, performing those operations repeatedly. How long? As long as the condition is true. Condition क्या है? Till the time value of counter is less equal to limit. When it crosses limit, that's the time when the condition will be false and the program will stop. Once it is performing the operations repeatedly, and the day when the counter value becomes 100, 101, condition will be false, it will stop. Counter value has become 101. Watch it. It has printed till 100, but counter became 101. So when it checked for the condition is 101 less equal to 100, condition is false. And when the condition is false, it has stopped. So that's how we execute this kind of loop. Any questions regarding this? Have a look at this construct. I'm saving this particular file by the name as while1. I'm also printing this file and sharing it with you for the reference. Have you all received the file? Have you all received the file?
Yes, sir.
Yes. Now that we saw how to stop that execution of the loop by using this variable called as counter, okay, it's time for us to take another example. But this is an example that you will solve for me. Okay, so let's take a problem statement. Let us try and again keep it as simple as possible to begin with, and then later we will go ahead with a slightly more complex solution. Okay. Right. Accept an integer. Accept an integer. And calculate product of all integers and calculate product of all integers in the range of 1 to n. Now here we only displayed the numbers, correct? Now I want you to calculate product of all integers in the range of 1 to n. That means user gives 3. I want you to multiply all the numbers in the range of 1 to 3. 1 into 2 into 3 is what I want you to do. If a user gives number as 7, then I want you to multiply all the numbers in the range of 1 to 7. 1, 2, 3, 4, 5, 6, 7. Okay, do it and show me quick. Accept a positive integer in the range of 1 to n and display product of all integers in the range of 1 to n. Come on, tell me, Aditya, what's the problem you're facing? Aditya, share your screen.
Yes, sir.
Share your screen. Let me see what have you done. Let me see how are you thinking. If I start calling out your name, it shouldn't be the case that you run away from the class. Huh? Okay, so you have done the same thing that Viraj has done. Ashish, share your screen. Okay, this is another common mistake that Ashish has done. Okay, Okay, now let me tell you the mistakes. The very common mistake that we end up doing is including, listen to everybody listen over here. So we have some good examples. Including the statement that should belong to the body of, that should not belong to the body of the loop, we write it inside the body of the loop. That's a mistake that Ashish has done. Some
Sir, I have done
operation-
it purposely.
Pardon?
I have done it purposely to check my.
No. But then when you show it to me, then that checking should not be there. Okay. Show me the final solution. You cannot have the testing solution for me. So a common mistake is some statement that should not belong to the body of the loop is now belonging, you have written inside the body of the loop. That's something which is not acceptable. So you could rectify and show me the correct loop then. Prithviraj, share your screen. Make corrections, Ashish, and show me the screen. Share the screen again. Prithviraj, share the screen. Scroll down. Scroll down. Okay, that's not right. Okay, there's a logical mistake. Kaustubh, Bhagyashree, share your screen. Prithviraj and Ashish, do a dry run. वो step by step execute करके देखो. Prithviraj, do that step by step execution and check on your own. No, that's only the speed. Step by step execution के लिए you have to click on the 1, 2, 3, 4th icon. Fourth from the left. Fourth. Yes, and do that execution and check it out. Do it. Keep on clicking that again and again. So you'll understand where the control is going. Give the input. What is the input that you have given? Why haven't you shared the screen, Prithviraj? You have shared only the application, not the screen. Share the screen so that we can see the other windows also. Prithviraj, share the screen. Prithviraj, can you hear me?
1 second, the application is not responding.
Okay. Kaustubh, share your screen. Kaustubh, share your screen. Bhagyashree,
Yes, sir.
Bhagyashree, I would like to see your screen.
Yes, sir. Just a minute.
Kaustubh and Bhagyashree, you cannot just keep chat. आपको बात करना ही पड़ेगा. बताना, दिखाना होगा मुझे स्क्रीन क्या कर रहे हैं आप. Ashish, have you done the corrections?
Just a second.
Share the screen. Share the solution only directly. Okay, share the solution, Ashish. We'll discuss where the things are going wrong. Share the solution. Do whatever corrections you want to do and share the solution, Ashish. Stop sharing, share the solution with me. Bhagyashree and Kaustubh. Am I not audible?
So, am I audible? Hello? Hello?
Ashish, solution share करो.
Hello?
Let's see what Ashish has done. He is the one who is nearest to the solution. But then, what is the mistake? Let's check it out. Here is Ashish's solution. So let's go ahead discussing the solution.
Sir, there's a issue
Let's
in
discuss
this
it. Look,
condition.
what you have done is also good, but then I'd said common mistakes kya hai? I'll show in the notes also. I have written the same thing. What you have done is not something which is very different. It's a very common thing that people end up doing. Statements mark karke rakho. Statements that do not belong to the body of the loop, belonging to, have been written inside the loop. Body kahan se kahan tak hai? Ye sari body hai. So there is some statements over here that should not be a part of the loop that you have written inside the loop. So that is a mistake over here, nothing else. Okay. Now, even before we go ahead solving this, discussing the solution that Ashish has written, Monica, you tell me, if I give input as 5, how many outputs you would like to display? Monica, you tell me, if I give input as 5, how many outputs you would like to display?
Up to
How count mein puch raha hu. How many outputs you would like to display? How many numbers you would like to display? If my input is 5. 5. Okay, Bhagyashree, how many
Five.
outputs you would like to display?
1.
1. Prithviraj?
One.
1. If I tell you a number, if the question was product of all integers in the range of 1 to n, तो एक क्या output display करना है? 1 into 2 into 3 into 4 into 5 का जो final answer रहेगा, that is what is to be printed. We are not required to print all the numbers in the range of 1 to 5. ये 1 to 5 के सारे number print नहीं करने हैं, या उनका multiplication भी नहीं print करना है. At the end, after we have completed the operation of multiplying all integers in the range of 1 to n, whatever is the final answer that we would like to display. So let's see. We ask him to enter integer. He says, please enter a non-zero integer. I'll say non-zero positive integer. Positive integer. Here we go. Then he accepts the limit. Before that, he has taken some variables. One is limit, another is counter. This limit and counter will take care of controlling the execution of the loop. And product will take care of fulfilling your requirement. He has taken counter value 0 and product value 1. And he says counter greater than limit. Now tell me, if user enters limit as 5, counter ka initial value 0 hai, will 0 be ever greater than limit?
Yes.
Ashish?
No, sir.
So ये condition गलत हो गया अपना.
Yes.
It should be counter less than limit. Okay. So not greater than limit. तो counter का value 0 है. Limit अगर आपका 5 है, तो 0 is less than 5, yes. 1 is less than 5, yes. 2 is less than 5, yes. 4 is less than 5, yes. 5 is less than 5. False. So when it becomes 5. But why start counting with 0? We are humans and humans start counting with 1. So why not start counting with 1? And do this operation till the time counter ka value is less than or equal to limit. So 1, 2, 3, 4, 5 count karo na. Instead of counting like 0, 1, 2, 3, 4, few zeros to start correct. Start counting with 1. So I'll rather take this counter as 1. And plus, what I'll also do is I'll assign the value to this particular counter variable over here. The reason for that is I'll have an idea as to what is the initial value of the counter. So I'm keeping the statement near to this condition. Okay, so we have defined some variables. So I have limit, I have counter, I have product, and product is initialized to value as 1. Okay, so initially itself we have initialized the value to 1. We ask user to enter positive non-zero integer, user enters some limit. Say user enters number like 5. We have taken counter as 1. For a moment, let's keep these statements aside because these were the statements which are at the wrong place. Okay. And let's also keep this thing aside while that was correct. Here, this form of loop that we have constructed will ensure that this loop will get executed 5 times. Okay, say, suppose here I just print the number, counter, like last time. ये last time का ये example है. If I just want to print counter, for the first time counter is 1. 1 less than 5, yes. It will print 1, counter will become 2. 2 less than 5, yes. It will print 2, it will become 3. 3 less than 5, yes. It will print 3, it will become 4. 4 less than 5, yes. It will print 4, it will become 5. 5 less than 5 is true, it will print 5, it will become 6. 6 less than 5 false बाहर आ जाएगा. So let's trace this code once again. Understand what we had done earlier. Same example, what we had solved earlier. Let's solve it again. Limit is initialized, both of them are initialized. We ask the user to enter the positive number. So we have asked the user to enter a positive number, and user enters a positive number. Say user enters a positive number, and that is 5. User enters a positive number, that is 5. Watch it. Look at the variables. Counter uninitialized है, product में 1 है, limit में 5 है. Watch everybody. That's very important. Now we are here. Counter value has been set to 1. देखो, counter value has been set to 1. Now we'll be checking for the condition. Is counter is equal to limit? वो condition true है, so we go inside. We print the value of counter. Counter का current value is 1, so 1 will get printed. And then we're saying counter is equal to counter plus 2. Counter value 1 है, 1 plus 1 will now become 2. We go back. We will now again check for the condition. Is 2 less than 5? Condition is true. It will go inside and print counter once again. If true है, it comes here, print the value of counter. 2 plus 1 becomes 3. 3 less than 5? Yes, it will come inside and print the value of counter. 3 plus 1 becomes 4. 4 less than 5? Yes, it will come inside and print 4. It becomes 5. 5 plus 4 plus 1 becomes 5. 5 less than 5? Yes, it will print 5. It becomes 6. देखो अभी यहाँ counter 6 बन जाएगा. Counter is 6. Is 6 less than 5? Condition false. We go out and we stop. The program has stopped. So ये तो हो गया loop we have constructed. So first construct a loop that will get executed that many number of times. So we want to perform that operation of multiplication 5 times. So first construct a loop that will get running 5 times. So एक loop construct कर लिया हमने. Now once you have constructed a loop which will get executed 5 times, then perform the operation. आपको क्या करना था? Multiply करना था. So I take that particular variable over here now. Product that we had. Product. And that product was to be multiplied with what? Product into counter. So if I say product is product into counter, what difference will it make? Let's try and do that. But once we come out of the loop, we'll print the value. So here is where we'll actually print the value result. Watch it. Just focus on this loop now, how it runs. We will again start tracing the code step by step. Everybody watch the variables. So we go here, we ask it, we create the variables. Note, product has been initialized to value as 1. That was very important in this case. If it was uninitialized, you'll get the unexpected result. We ask you to enter the limit. User enters limit as 5. So we are interested in multiplying all the integers in the range of 1 to 5. Here we go. Counter value now is 1. Watch, counter is 1, limit is 5, product is 1. These are 3 variables that we have created. Counter 1 hai, limit 5 hai, product 1 hai. Now we check. Is counter given limit? Watch over here. Is 1 less than 5? Watch over here what I'm saying. Is 1 less than 5?
Yes.
Yes. So we'll now go inside the loop and then we'll multiply product is equal to product into counter. Tell me what is the result? 1 into 1?
1.
1. So the result is 1. Counter is equal to counter plus 1. 1 plus 1 now becomes 2. So second time we go inside. Again we check. Is counter is equal to limit? Is 2 less than 5? What's the variables? Is 2 less than 5?
Yes.
So we go inside. Counter is equal to count product. Product is equal to product into counter. Product value 1 है, counter value 2 है. So 1 into 2 becomes 2. Look at that, it becomes 2. Counter is equal to counter plus 1. 2 plus 1 now becomes 3. Again we go back and check. Is 3 less than 5? Condition true है. So if we go inside and we multiply, product is equal to product into counter. 3 into 2, that now becomes 6. And counter will counter plus 1. Counter value 3 है. 3 plus 1 now becomes 4. Is 4 less than 5? True है. So again we come inside. Product is equal to product into counter. 6 into 4, that becomes 24. Watch it, product becomes 24. Counter is equal to counter plus 1. Counter value 4 tha. 4 plus 1 now becomes 5. 5 less than equal to 5. Condition is true. We go inside. Product is equal to product into counter. Product का value फिलहाल 24 है. Counter का value 5 है. So 5 into 24 becomes 125. 120. And then we come counter plus 1. 5 plus 1 now becomes 6. And we check. Is 6 less than 5? Condition is false. Since the condition is false, we'll not go here. Rather, we'll go here and we start displaying the result. क्या कह रहे हैं हम लोग? Product of all integers in the range of 1 to 5 is 120. There is printed the message. Product of all integers in the range of 1 to 5 is 120. And that's nothing but we have written an example to find factorial of a number. In the factorial का problem solve किया, nothing else. So this was an example to how to calculate factorial of a number. So this counter was taking this counter, or this is a determinate loop or counting loop. Counter is used over here to determine how many times the operation has to be done. This is an operation that we are performing multiple times, whereas counter is only keeping a track कि कितनी बार ये operation हो रहा है. So let me save this particular program. Since it is done, file, save as. I'll call this as while 2. I'll print and share this solution as well with me. Now tell me, have you all understood this solution? I share the solution with you.
So
Have you
तुम्ही-
understood? Yes, please.
तुम्ही जे आउटपुट डिक्लेअर केले ना सर, किंवा प्रोडक्ट ऑफ ऑल इंटिजर्स इन द रेंज ऑफ 1 2 आणि पुढे 3 डॉट टाकलेत ना सर, ते माझ्या इथे आयडेंटिफाय नाही होत, तिथे एरर येतोय.
We will not that close. Whether I clicked on new line or not, that is what is deciding.
न्यू लाईनला टिक नाही करायचं का मग सर?
Of course, when you click on new line, then you get those 3 dots. When you don't click on new line, you will not get those dots.
ओके.
The
Not
solution,
supposed to type in dots. Yes,
the solution नाही भेटला.
solution नाही मिळालं. कळालं नाही का मिळालं नाही?
मिळालं नाही, तुम्ही पाठवलं.
Others have received it?
No, sir.
Sorry,
No.
मैंने शायद गलती से
No,
आशीष
sir.
को भेजा से. नहीं, I'll send it to Ashish by mistake. Have you all got it down?
Yes,
Yes.
sir. Yes, sir.
Okay. Now, we'll go slow. We are in no hurry to rush through and complete this little thing. But I need you to get the right concept. These are examples for which probably I will not use while loop. But again, I'm telling you, I'm taking these examples only for sake of practice. The reason is like, I want you to be comfortable using the looping construct. Then we'll see which looping construct to use when. But first, at least let's get comfortable with this looping construct. Okay.
Sir,
Yes, please.
Sir, that you had assigned one thing there, n plus one, counter plus one in sir, in that loop, was that indicator?
Yeah, it's an indicator or it's a loop control variable because that is keeping track how many times the loop has to run. Because when the counter the value becomes more than limit, then the loop stops. So that is what is keeping track. The counter is keeping track how many times the loop should get executed. So you first identify, construct a loop. Whenever you come across a problem, first construct a loop that will get executed required number of times, and then add that operation, that product is group product into counter या जो भी करना था आपको, into the body of the loop. If that operation was to be performed that many number of times, जो काम आपको repeatedly करना है वो बाद में डालो. पहले ये loop construct करो which gets executed required number of times. So that counter is equal to limit and counter is equal to counter plus one. We have constructed a loop which will get executed limit times, and then perform that operation, whatever operation you would like to perform limit number of times. Okay. So one more question. A very similar question, slight twist है, similar question है, similar है, almost similar है. Note down. Okay. Sanjay has asked for a break. Do we need 5 minutes break? Raise your hand those who want 5 minute break. Especially hostelites, don't you want to get your lunch, dinner or something? Okay, what we'll do is we'll take 5 minutes break and we'll continue. It's 9:19. Okay, we'll take 5 minutes break. We meet at 9:25. Okay, 5 minutes break and we'll continue. 5-6 minutes break and we'll continue. Take another problem statement. Solve it once again. Make a serious attempt to get this one right. Okay, note down the problem statement. Accept the base number and the exponent.
So can you repeat?
Accept a base number and the exponent accept the base number and the exponent and calculate the result of base number raised to exponent and calculate the result of base number raised to exponent. That means your base is 3 and exponent is 4. 3 to the power 4 का जो result है that you have to display, that means 3 into 3 into 3 into 3, 4 times. So you are supposed to accept base and exponent and base to the power exponent का result आपको display करना है. And this time around, after you solve it, I want to see everybody's solution. So there is no choice. Your solution गलत है, सही है, whatever it is, I want to see your solution. What have you done? So no excuse. You have to show me the solution, without which you cannot go home. And if you run away, maybe I'll drop in at your place to see the solution. Okay. So you have to show me the solution. Right or wrong, that doesn't matter. But start solving. Whatever you do, show me what have you done. Everybody.
Can you repeat the question?
Pardon?
Sorry, repeat the question.
Accept the base number and the exponent. And display the result of base raised to the exponent. That means x or y accept karo and x to the power y, x raised to y, display karo result. And raised to का मतलब क्या होता है? The number is to be multiplied by itself that many number of times, exponent number of times. 2 to the power 3 कहते हो या 2 to the power 5 कहोगे तो 2 is multiplied itself 5 times. Nothing else. 2 into 2 into 2 into 2 into 2. I'm saying this example is nothing different than what we have solved in the last two examples. वही है, nothing different. Just keep your cool and solve it. Ankita, I said turn on the camera. क्या problem है? Sagar, keep your camera on. And if you have some issues, let me know. Solve करो, चलो everybody. And I want to see everybody's solution. No excuse to anybody. Yes, anybody has completed? Let me see what are you doing, Aditya?
Sir, I didn't complete. Incomplete. Sir, 5 minutes.
Show me what have you done. Whatever you have done, let me see. Share your screen, quick. अरे आपने एक्सपोनेंट एक्सेप्ट ही नहीं किया, कैसे चलेगा? The basic thing is what are the inputs, what are the output, we have to identify. अगर आप input लोगे नहीं, how will it work? These are common mistakes. You are skipping the things.
Yes, sir.
Okay, take corrective action. Viraj, दिखाओ what have you done? Share your screen, Viraj. Increase the size slightly. We have not taken enough inputs, Viraj. Read the question. How many inputs are required? Check it out.
Sir, exponent.
How many?
सर एक्सपोनेंट रह गया.
तो कैसे चलेगा? Basic things about programming was what we said. Read the problem carefully, understand the problem, define the problem, understand the requirements, find out what all inputs are there, what all outputs are there, and then you can proceed. Why should you be in a hurry?
Sir, एक
हाँ.
बार सेंड किया चेक करो.
Okay. Ankita, share your screen. Let me see what have you done. Ankita, share your screen. Let me see what you have done.
Sir, I didn't solve it.
कुछ तो क्या रहेगा? The
नहीं
other two
सर,
have
वो मेरा विंडोज को कोई तो प्रॉब्लम ही दे रहा है,
what problem?
एरर दे रहा है. That
solve it.
file.
Solve it on paper and show me send the photo.
Okay.
Solve it on paper. Very good, Ashish. It looks correct. Test the code, Ashish, and see. Test करके देखो.
Okay.
Take some sample values for whom you know the inputs and see what happens, whether it runs
Okay.
correctly or
Okay.
not.
Okay.
First glance, it looks correct. Rahul, share your screen. Rahul had a problem. Sanjay, share your screen.
I think it's good.
Sanjay, scroll करो नीचे. Always write positive logic. Base number greater than equal to counter. Okay. Yeah, counter is equal to base number. That would be correct, ना? सोचने के लिए. Although this is the right way to do. सही है, but just change it, ना? Condition. अरे, I said condition. उल्टा डालो ना condition. Counter is equal to base number, base count. Base number greater than counter. Positive सोचो, हाँ. और काउंटर का स्पेलिंग क्या है? स्पेस चाहिए ऑपरेटर के आगे पीछे. Space before and after the operator, less than equal to, before less than equal to, after less than equal to. Okay.
Exponent.
और बेस नंबर देखो कैसे लिखा है यहाँ, NU both capital. And who will display the output? If you study a lot for the exam, and if you don't appear for the exam, is that of any use, Sanjay?
No, sir.
संजय,
No,
बहुत पढ़ाई की, एग्जाम के लिए भी गए और पेपर अटेम्प्ट नहीं किया, चलेगा क्या? या पेपर अटेम्प्ट किया और दिया ही नहीं, सबमिट ही नहीं किया, चलेगा? Where is the output? You haven't displayed the output. Every program we write for some output. Ashish, have you tested the code?
Yes, sir.
Is it working?
Yes.
Very good. It was correct. Monica, share your screen. How can you accept two inputs directly without message? How will the world user understand पहले क्या enter करना है, बाद में क्या enter करना है? त्याच्या मनात जाऊन सांगणार का त्याला काय टाकायचंय? Will he understand what is there in your mind?
Sir,
So no input will come without message. Blank screen, user keeps wondering what is to be entered. कैसे चलेगा? So before you take any input, you should always give a message to user. What are you expecting him to enter? Bhageshri, share your screen. Bhageshri, share your screen. What's wrong, Bhageshri? Why aren't you not sharing the screen? Scroll down. Scroll down. Scroll down. Scroll up. Up, I said. More, I want to see, go up. And this will not work right. Bhageshri, test your solution. There is a silly mistake. Variables, remember what I had said. Variables whose value is read for the first time. Any variable to which you are assigning value for the first time, that need not be initialized. Every other variable whose value we read for the first time, that variable should be initialized. तो golden rule आप भूल रहे हो. Sagar, show me what have you done. Ankita, share the solution. Paper पे किया हुआ दिखाओ हमें. Who is this?
Sagar, sir.
सागर, हाँ. सागर, आपने सिर्फ बेस नंबर एक्सेप्ट किया. एक्सपोनेंट कहाँ है आपके पास? You haven't accepted the exponent. There are two inputs in this program. Question क्या था? Accept the base number and the exponent. So at least to begin with, read the question carefully. Accept whatever input is expected. जो input बोले गए हैं वो सारे accept करना जरूरी है. If you don't accept those inputs, how will the program work? Accept those inputs. Ankita, share karo solution. Image दिखाओ. If you have solid on a paper, show me. अंकिता, सॉल्व किया है, दिखाओ जो भी किया है, कैमरा के सामने रखो. लेट मी सी व्हाट हैव यू डन. फ्लोचार्ट चाहिए अंकिता है. वी आर टॉकिंग फ्लोचार्ट्स राइट नाउ.
Yes, sir, but I thought that I'll draw it rough, so I'll make it.
रफ नहीं, फ्लोचार्ट itself is almost rough ना. और क्या होता है? It's not the actual program. So draw the flowchart quickly
Okay.
with all the symbols.
तर मी एकदा शेअर करू का?
करा ना शेयर. Scroll up. अरे स्क्रॉल करो ऊपर.
हाँ किया है ना सर.
और चाहिए? आई कैन सी.
एक्सपोनेंट.
अरे स्क्रॉल तो करो ऊपर. लेट मी सी ऊपर से क्या किया. यू आर शोइंग ओनली द लास्ट पार्ट.
हाँ हाँ. हे अननेसेसरी इंटीजर स्क्वेअर वगैरे.
अरे तुम स्क्रॉलच करना नसेल तर हाऊ डू आय नो. आय वांट टू सी द कोड फ्रॉम द बिगिनिंग.
ओके ओके सर, केलंय मी. दिसत नाही का?
Others can see it. I can't see.
No, sir. He has shared the Chrome or Edge link. I mean app.
अच्छा. अरे पूरी स्क्रीन शेयर करो राजा. We can see. ये क्या है? ये क्रोम है क्या आपका? हाँ, ये you should share the Chrome screen. Logarithm शेयर करो राजा.
हाँ हाँ. ओके.
Hold on. Let me see from the beginning. Scroll down. Scroll. ये उल्टा हो गया, x रेस टू y की जगह y रेस टू x का आंसर आ गया. Okay. So make changes. A raised to b बोला है तो you have given me answer of b raised to a.
Okay.
Okay. Ashish has solved this particular solution correctly. So let's have a look at the solution that Ashish has solved. Since he has got it right. Prithviraj, have you done that? Share your screen, Prithviraj. Let me see. What have you done? Okay. So what is stopping you? What should the condition be? How many times you would like to perform the operation? Prithviraj? Prithviraj, can you hear me? Can you hear me, Prithviraj?
Yes, yes.
How many times you would like to carry out operation?
Will we get the result like?
No. Tell me the number. How many times you would like to need to carry out an operation? I said A raised to B means A is multiplied B number of times.
Yes.
So how many times you have to carry out operation in this case?
Like till the limit.
No, there is no variable as limit. We have only
Means-
two variables, base and exponent.
Like the exponent.
So write down that condition.
Yes.
Everybody pay attention. Ashish has got it right for the first time. Good work, Ashish. Let's have a look at his solution. I may make one small change, but otherwise the solution is good. He has taken a variable called as base number. It could have been real, it could be integer, but I had asked you to accept an integer or number, I don't know. If I had said number, you can take it real. If I had said integer, you better take it as integer. Then we have a variable as exponent. It's best if you take it integer, neither 2 raised to 5.6, it will be very difficult. So base and exponent are two variables. One is counter. So counter is our loop control variable. That is just to keep a check as to how many times the operations has to be performed. He has taken variable as answer, result, whatever name you can give. Enter a non-zero positive base number. Very correct. Then he is accepting the base number. Enter a non-zero exponent. Now, exponent could have been 0. Okay.
Sir, mine program is also done.
Okay. Let us check this what he has done first. Enter a non-negative integer, non-negative exponent. I'm just saying non-negative. He may enter 0 as well. Okay. He may enter 0 as well. And then counter value for the first time is 1. Let's take an example now. Watch it, everybody. Base number he enters 5. Exponent he enters as 0. So 5 raised to 0. Ashish, answer क्या आना चाहिए?
1.
1 आना चाहिए. Will your solution give answer as 1?
Yes.
Okay. So that's correct. Let's see. Base enter किया 5. Exponent enter कर लिया 0. We have taken counter as 1. Answer is 1. And we change counter. Counter का initial value 1 है. Is 1 less equal to 0? True or false?
False.
False है. False है तो we directly go out and we say the base number raised to exponent is answer. Okay. So answer के initial value क्या है 1. Anything raised to 0 is 1. So that first condition is correctly handled. next condition. But before even we go ahead with the next operation, understand base raised to power 2 raised to 3. That means 2 is to be multiplied with itself 3 times. So multiplication operation has to be performed repeatedly. 2 into 2 into 2. 2 into 2 is 4 and 4 into 2 is 8. Kind of thing. So we have accepted the exponent. Where then we have a counter, we have answer. यहाँ तक सब कुछ ठीक है. Then counter, let's go to exponent. So assume करें कि counter का value 1 है. Assume कि it is 1 and exponent is suppose 3 and base is 2. So 2 raised to 3 का आंसर हमें चाहिए. So each counter that is 1, let's go to 3. Yes, we say answer is equal to answer into base. What I would suggest is always write, keep space between the operators. It's a good practice. Okay, so answer is equal to answer into base number. Answer value is 1. Base number is 2. So 1 into 2, answer becomes 2. Counter is equal to counter plus 1. That also becomes 2. 2, let's go to 3. Yes. Base number is equal to answer into base number. Answer was 2. 2 into 2 now becomes 4. Counter becomes 3. 3, let's go to 3. Yes. Answer is equal to answer into base. 4 into 2 becomes 8. Counter becomes 3 and 4. And 4, let's go to 3. Condition is false. We come out and we display the result. It was a perfect solution. So let's test it with some values. We have a variable. All variables. Only answer. None of the variable has been initialized right now. Look at this base, exponent, counter, answer. None of them have been initialized. Uninitialized value. We ask user to enter the base. User enters base as 3. Watch it. Huh? We ask user to enter a non-negative exponent. We ask you to enter non-negative exponent. And user enters a non-negative exponent.
Sir, click it from that window only.
Let's start again. We have these 4 variables. We have been asked to enter a positive base number. I enter 3. Then we have been asked to enter a non-negative exponent. User enters 4. So 3 to the power 4. What is the result for 3 to the power 4?
81.
Okay, let's see. Now watch this variable explorer at the rightmost side. उस पे ध्यान दो. अब यहाँ loop में देखो. Counter का value is initialized to 1. Counter initialized garbage. Now he initializes to 1. Then answer was also to be initialized. Has he initialized the variable answer? देखो. He hasn't initialized the variable answer. Oh, he has. Answer is equal to 1. So answer का value बन गया 1. That was very important. अगर answer initialize नहीं करता, तो here first time we are reading the value of the variable. किससे multiply करेंगे? That would be garbage. So counter लेंगे तो exponent. Watch it. Counter value is 1. Exponent value is 4. Watch it everybody. Yeah, where we are. Counter value is 1. Exponent value is 4. And we are checking. Is counter less than exponent? Is 1 less than 4? Condition is true. So we go inside. We say answer is equal to answer into base. Answer value 1. Base value 3. So 1 into 3 ka result is stored in answer. So answer which was 1 right now will now become 3. Watch it. It has become 3. Then counter is equal to counter plus 1. This counter concept was used only to keep a track. How many times the operations have to be done? The same question I asked Prithviraj. If I have to display the result of 2 raised to 5, so 5 is exponent, 2 is base. So I would like to perform the operation multiplication 5 times. That is exponent number of times. So what Ashish has done, he has used this counter only to construct a loop that runs exponent number of times. Counter is equal to exponent. And बार-बार क्या कर रहे हैं? Multiply ही तो कर रहे हैं. Isn't it same like what we had done earlier? Addition किया था, multiplication यहाँ वही वैसे ही है. Okay. So here we say counter is equal to counter plus 1. Counter value 1 है. 1 plus 1 now becomes 2. Okay. And then we again go and check for the condition. Is 2 less than 4? Yes. Answer is equal to answer into base. Answer value 3 है. Base is also 3. 3 into 3 now becomes 9. Counter is equal to counter plus 1. Counter now becomes 4. Again we check. Is 4 less than or equal to 3? Counter value 3 here. Is 3 less than 4? Yes. So we come inside and we check. Answer is equal to answer into base. Answer value 9 है. 9 into 3, that becomes 27. That becomes 27. Counter is equal to counter plus 1. 3 plus 1 now becomes 4. Again we check. Is 4 less than 4 condition still true? So we go inside. Answer equal to answer into base. 27 into 4. 27 into 3 it will do. And 27 into 3 now comes out to 81. Look at that. It has come out to 81. And counter is equal to counter plus 1. Counter value 4 है. 4 plus 1 now becomes 5. And we check. Is 5 less than 4? Condition is false. Since the condition is false, we come out and we start displaying the 3 raised to the 3 raised to 4 is 81. The निकाल दो. The की जरूरत नहीं है. The rest all solution is right. Okay. Yeah, I have to just get rid of this and we'll run this particular code. Next time we have been asked to enter the positive number. I say 2. Exponent मैंने कहा 5. कहेगा ये चलेगा 5 बार और फिर रिजल्ट डिस्प्ले करेगा 2 raised to 5 is 32. Okay. So that's how it's working right. Very good work, Ashish. Everybody have a look at this and let me know if anybody has an issue. किसी को समझ में नहीं आया होगा तो पूछिएगा. There is nothing wrong if you don't understand. But if you don't ask, that's problematic. Have you understood this logic? What has it done? So this counter, this example, counter less equal to exponent and counter is equal to counter plus 1. Last time we had said counter less equal to limit and counter is equal to counter plus 1. So loop executed limit number of times. In this case, the loop will execute exponent number of times. We are saying counter is equal to exponent, counter is equal to counter plus 1. And so exponent number of times, we are just going to say answer is equal to answer into base number. So 2 is multiplied with 2 and stored in the result answer kind of thing. So we'll keep on multiplying the number that many number of times. Okay. Now we could improve on this Ashish solution slightly. How to improve on the solution slightly? Let me explain it. Now here, answer value is taken as 1. So counter is equal to counter less than exponent. So here I don't see any scope of improvement. I could have initialized this particular variable to value as base number. Then one iteration would have been reduced. But अगर exponent 0 है तो मुश्किल हो जाएगा. Because anything raised to 0, answer has to be 1. So this is what we can do most. It's a perfect solution that has now been designed. I'm sharing the solution with all of you. Who gets first, who gets later, that's not very important. After all the discussion, whether we have understood or not, that's more important. Have you realized what mistake have we created? That is more important. Somebody's going to get it first, somebody's going to get it last. First, last, it's not a competition about who gets it first. More important, you have to understand what is happening. So now let me know quickly, have you all understood the solution, what has been done?
Yes, sir.
आदित्य क्या डाउट है?
Yes.
अंकिता, मोनिका, Monica, what's the problem? Now take another question. Okay. One question as an assignment. I will not stress too much. It's slightly different than what we did till now, because all examples that we did were exactly the same. So thoda sa alag question, slightly different. Okay, but on the same lines. Take the question, solve it, and be ready for the next session. कल लेकर आना इसका solution. Accept. Ten integers from user. Now they can be positive, negative, anything. Huh? Accept 10 integers from user. And note करके रखो, it can be positive, negative, any integer. Huh? Accept 10 integers from user. And display the and
Sir, can
display
you please repeat?
accept 10 integers from user and display the largest and the smallest amongst the 10 integers, largest and the smallest amongst the 10 integers. So whatever 10 numbers user enters, you have to display which is the largest and which is the smallest, both, along with average of all the numbers entered. Along with average of all the numbers entered. So he's going to accept 10 numbers. So you're going to do 3 things. You're going to display which is the smallest number, which is the largest number, and what is the average of all those numbers is what you're going to do. So that's an exercise for all of you. Take your time, solve that exercise, and don't forget to complete the assignments which have been posted on the e-learning portal. Those are also something that you have to complete, and this is also something that you have to complete. Okay. So assignment भी करते रहो, but ये कल का एक example solve करके ready आ जाइएगा.
Sir,
And don't miss the sessions. I
Yep.
know many of you know it, but we still commit mistakes. So यही purpose activity का ही है. You keep on solving those examples, so those mistakes are eliminated. These silly mistakes you don't commit. And you have to show me the solution, right or wrong. You have to show me the solutions. So never be scared of sharing, however wrong or bad it may be. Share. I can tell you how to think. Prithviraj showed the solution. He was confused about how to write a condition. Then I said something that will give a hint as to how to look at that particular problem situation. Okay. Ashish, first time he wrote that code, he wrote that statement inside the body of the loop. He will never commit that mistake again. The condition was incorrect. So once you show me the code, then I understand you better. How are you thinking? I can help you out better. But if you're going to hide the code from me, nobody can. It's like going to a doctor and not telling the doctor what's the pain. Doctor से बात तो करो, बताओ उसको pain क्या है. He can help you out better. So I can help you out better, provided you keep me on sharing the code. So always share the code. Don't hide, don't run away. Programming is simple. It's enjoying kind of activity. You'll enjoy it. You'll feel as if the entire world is in your hand, provided you start on the right note. Once that fear comes in your mind, then nothing can happen. And these are the only opportunities where we have a chance to fail, to go wrong. The very purpose why you are here for the session is because you would like to improve. That means you are not expert in that area. So I am there to help you out to whatever extent I can help you. So make use of this opportunity, this particular sessions. Ask questions, show me your solutions. Let me understand you better. I can help you out better. So on that note, we'll stop here today. See you tomorrow. Take care. Love you all. Bye-bye.